Hello everyone, in this video I wanted to talk about verifiable random functions. So these are composed of three parts. First we have the generator function g. All this does is it produces key pairs composed of a public key and a secret key. Next we have the main function f, which is parameterized by the secret key. It has one input, which we will call x, and this outputs a pair labeled r and pi. And r is going to be the randomness, and pi is the proof. This is a value that lets others check that r was computed correctly. So lastly, we have the verification algorithm v. This is parameterized by the public key. It is given as input x, r, and pi, and it will either accept or reject. Accept being the case if r and pi were correctly computed from the function f, given the secret key and input x, and it rejects otherwise. Okay, next let's talk about the three properties that we care for verifiable random functions to have. The first one is called provability. And this essentially states that the verification function v will always accept properly computed values of r and pi. Pretty straightforward. The second one is uniqueness. This essentially states that we cannot construct alternative values of r. The idea is once we have x, that should determine the randomness r and the proof pi. It should not be the case that someone is able to create an alternative value called r prime along with a possibly different proof pi prime, such that the verification algorithm on both of these inputs accepts. This should not be the case. If it was, then you will end up in situations where we start by using one value of randomness, and then later on someone tries to use a different one, claiming that it's the correct one to use. So this is essentially the security property that we want to have. And third, we have pseudo-randomness. And this basically states that r is random. In other words, everyone looking at the value of r should not be able to distinguish it from a sequence of bits that are chosen truly at random. So this is of course useful because now we have a situation where we can generate r and then use that in whatever application we are running that needs random bits. Something to think about is if we just consider the first two properties of provability and uniqueness, that basically gives us a secure signature scheme. And then if we just consider property 3 in isolation, that is essentially a pseudo-random generator, which is a fancy way of saying a function that outputs random bits. So another way to think about this is if you combine these properties, we get verifiable random functions. So you can think of a verifiable random function as an object that has the properties of both a secure signature scheme and a strong pseudo-random generator. Okay, lastly, I wanted to motivate all of this discussion. So why do we care about verifiable random functions? What makes them useful or interesting or compelling? So imagine we have a distributed environment In other words, we have a collection of participants who are coming together to try to produce some sort of useful computation. The idea is verifiable random functions allows everyone to agree on the same randomness. This is a pretty useful ability to have. And in addition to that, we can do so in a fair and trustless manner. Fair because of the third property that R is random, meaning no participant will be able to bias or influence the value of R. And then trustless because we have a verification function v that lets everyone check that R was correctly computed according to protocol. And then in addition to the above, this can be done in a non-interactive way. The idea is previously, before verifiable random functions came along, in order to accomplish all this, let's say you had two parties, they would have to send messages back and forth in order to accomplish the above. And as you can imagine, if you had more parties in your system, they would all need to send messages back and forth to each other, and that can get pretty complicated pretty quickly. So this is a situation we want to avoid, and verifiable random functions let us do that. In other words, we have a system that has low communication complexity. And this lets us design more efficient protocols. And that is all I wanted to say about verifiable random functions.